Hello, ladies and gentlemen. Welcome back to math. Today we're going to learn about tangents. Okay? Remember, parts of a circle, a tangent was a part of that circle. Okay? If you guys remember, a tangent passes through the edge of the circle. Okay, so we have our circle here. We have our center. We have a line that touches the circle. Okay? Now, we have a radius that goes from the center to where the tangent touches, okay? Our radius, guys, okay, in this circle is all right, we have 8 for the radius, okay? We want to find, okay, the distance from here, from the A, let's say this is A, okay? The intersection from the tangent to our, okay, let's do this so you guys can see the top one. We have A, we have the intersection of the radius and the tangent, which is B. We have circle P. We also have a line, okay, that goes from, let me do it a little better, from the center to A. Okay, let's do this, do that. Try to make it a little more noticeable. Okay, so we have a line, or we want to find the distance, should I say, from P to A. It tells us that the radius is 8. Okay, it also tells us that from A to, let's go with C, okay, because we have another vertex there. We have two lines that intersect. We have the circle and the line. From A to C equals 9, okay. We have to solve the distance from P to A, okay. So distance from P to A, okay, or A to P, doesn't really matter, either one works, or A to P, okay. Notice that it already gives us what A and C is, which is 9. So we can say that A plus C, okay, should say A plus C, AC plus CP equals AP, okay. Since we're looking for AP, we know that AC equals 9, so we can say 9 plus something equals AP. Guess what? We know what CP is because we know that from C or P to B is a radius that is 8. So any line that goes from the center to the edge of the circle is always a radius. So if we already have one radius that is 8, that means that CP is also 8. Therefore, we have 9 plus 8 equals AP. So 9 plus 8 is 16, 17 equals AP. So line AP from A to P is 17. Okay? Now, what if I wanted to find AB? Okay? If you want to find AB, we already have everything there to solve for it. Meaning, what kind of triangle is this if you really look at it? I will say this. When you have two radius, it creates a 90-degree angle, which is also known as a right triangle. Okay? There's an equation for right triangles when solving for them. If you guys remember from a previous video, across from your 90-degree angle is always your hypotenuse. Okay? Because the equation we're going to use is known as the Pythagorean Theorem, which is a squared plus b squared equals c squared. Okay? All right, now that we have that equation in there, we can say that, remember, always across your 90-degree angle is C. So we know AB is C. So we don't know what that is. That's what we're trying to solve for. We have an X. We know what A and B is. Remember, A and B really doesn't matter which one's which, as long as you always know what C is. You're across from 90. So 8 can be A or B, okay? I'm going to use it as A. So we have 8 squared plus, this is where, keep in mind, we have two numbers, or technically we already solved it, which was 17, right? So we have 8 plus 9, which is 17. So 17 squared equals X, okay? Or C squared. Let's go with C squared for now. C squared. So 8 times 8 is 64. So we have 64 plus 17 times 17. Let me get a calculator. We have 17, okay, times 17, which equals 289. So 289 equals C squared when we have an actual answer for A and B. We can actually combine because now they're just numbers, right? So we do 64 plus 289 equals 353. Okay, so 353 equals C squared. But remember, we're solving for just C or X. Okay, this is squared. Remember from a previous concept as well, the opposite of a square is a square root. Remember? Okay, so we have square root of 353 equals square root of C squared, where C or square root and square cancels out on the C. So we're left with C equals square root of 353, or C equals, let's see if it has a perfect square root. Shift square root of 353, which it doesn't. It equals approximately 18.79. Okay, if it doesn't have a perfect square root, that's fine. Leave it as the square root. If you want to use it as decimal, you can go ahead and do it as decimal. Okay, and that's it. We solve for the sides that the tangent created, okay, or the side of the tangent, should I say. All right, make sure you write it down in your notes. I'm gonna give you one similar, okay, for you guys to work out. All right, so here's your assignment for today. All right, guys, so the assignment for today is, you have two of them, okay? You have one where you have H as your center of your circle, You have x intersecting your radius and your tangent. Okay. We have YQ, which has a distance of 4. Okay. We need to find the distance between H and Q. Okay. We also have to find the distance between X and Y. Okay. All right. We have another one over here. Circle O. The radius is 1. You have A. You have B as your intersection, and then your C. Okay. B, C is 3. You need to find O, B, and also A, C. Okay. Remember, they're exactly the ones I did. They're just different numbers. Okay. If you have any questions, let me know. Okay. All right. Make sure you submit your answers as soon as you're done watching the video, guys. And I'll be waiting for your email.